Okay, so this is the second day of solving systems by graphing. Okay, we're going to spend several days on this. So just remember the three types. We have one solution, which is one point of intersection. We have no solution, which is parallel lines. And then we have infinite solutions, which is identical lines that overlap. So let's break it down. First thing we need to always make sure is that we are in slope-intercept form, which is y equals mx plus b. So if you look at number 1, they are both in standard form. So I'm going to take one at a time and convert. So I'm going to, for this first one, I'm going to add 3x to both sides. So y equals 3x plus 8. The second one, I'm going to add x to both sides. So I have x minus 2. So when I graph the first one, we're going to start at positive 8. Okay, and my slope is 3 over 1, so that means up 3, right 1. But when I can't do that, I go the opposite, which is down 3, left 1, 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 down 3, left 1. Okay, there's my first line. My second line, I'm going to start at negative 2 on the y-axis, but I'm going to go up 1, right 1. Up 1, right 1, up 1, right 1. Kind of seems tedious, but we got to do it. And then down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. You notice that there is a point of intersection right there. So then we have to figure out what that coordinate is. Starting at the origin, that is left 1, 2, 3, 4, 5. So negative 5. Down 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5, 6, 7. So negative 7. Negative 5, negative 7 is the point of intersection. Number 2, we're going to do the exact same thing. So we first need to convert both to slope-intercept form. First, we are going to subtract 5x from both sides. So 2y equals negative 5x plus 4. Divide by 2 to everything. So y equals negative 5 over 2x. Positive 4 over negative, or positive 4 over 2 is positive 2. The second equation, I'm going to subtract 9x to both sides. So I have 2y equals negative 9x plus 12. Divide by 2 to everything. So y equals negative 9 over 2 is negative 9 over 2x. And positive 12 over 2 is positive 6. For the first equation, we're going to start at the y-intercept of positive 2. And then we are going to go down 5, right 2. Down 5, right 2. Up 5, left 2. And then to finish my line. And then the other one, we're going to start at positive 6. And then go down 9, right 2. Which this is the point of intersection right there. Down 9 goes off the page. So this is my two lines. This is where they intersect, and this coordinate is, if I start at the origin, is right 2, down 3. So this is positive 2, negative 3. If I look at number 3, this one's not set up in standard form, so to get y by itself, we actually need to add x to both sides. So y equals x plus 5. On the second one, it is in standard form, so we are going to subtract x to both sides. Divide by negative 1 to everything. So y equals negative 1 over negative 1 is 1x. Positive 2 over negative 1 is minus 2. So number 3, if I start at positive 5, my slope is up 1, right 1, up 1, right 1, up 1, right 1, all the way. Or down 1, left 1, down 1, left 1, down 1, left 1, continued. On my second equation, I'm going to start at negative 2. And then I'm going to go up 1, right 1, up 1, right 1, up 1, right 1 to continue. If you notice already, these graphs had the same slope, which makes them parallel, which means they're never going to intersect, which means this is no solution. Number 4, to solve for standard form. Okay, this one's not set up in standard form, so we have to subtract x. negative 4y equals negative x plus 8. Divide by negative 4 to everything. So y equals negative 1 over negative 4 is 1 over 4x. Positive 8 over negative 4 is minus 2. The second one is already in slope-intercept form, so all we have to do is graph both. My y-intercept is where I start, so negative 2. I'm going to go up 1, right 4, up 1, right 4, or down 1, left 4, down 1, left 4, graph. Then my second equation, I start at positive 3. This is just another way to write 1 over 4x. So I'm going to go up 1, right 4, up 1, right 4, left 1, left down, left 4, down 1, left 4. If you notice, these also have the same slope, which makes them parallel, which makes them no solution as well. Number 5. So we're first going to convert to slope-intercept form by first subtracting x. So 2y equals negative x plus 4. Divide by 2. So y equals negative 1/2 x plus 2. The second one is already in slope-intercept form. So I'm going to graph the first one by starting at positive 2. My slope is down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. Same thing going the opposite direction, up 1, left 2, up 1, left 2, up 1, left 2. If you look at the second equation, they are exactly the same equation, which means they would literally overlap each other, which makes this the infinite or all reals, okay? Number 6, the first one's already in slope-intercept form, so all we have to do is convert the second one. So I have 4y equals negative 8x plus 12. Divide everything by 4. So y equals negative 8 over 4 is negative 2x. Positive 12 over 4 is positive 3. So if we start by graphing the first one that starts at y-intercept of 3, the slope is negative 2, which is negative 2 over 1, which is down to right 1, 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 up 2, left 1, up 2, left 1, up 2, left 1. If you look at the second equation, it is identical, so that means they are going to be identical lines, which makes this also infinite or all reals for this equation. So there are 3 types. Don't forget to convert to slope-intercept form first and then graph.